Image.
Hello.
Hello, everyone.
How's it going?
All right, so let's just give it a couple of seconds to let everyone get admitted, and then we will begin our discussion today. So today we have lab Thursday, ITS350. So we will go over the second lab assignment, which is the hash function. Okay. So I will go over that. So I just want to remind you as well that your first homework assignment, which is the secret key lab, those 4 problems, that was due, that's due today by 10 p.m. I saw that some of you sent me your lab reports via email. So during the lab session today, I will kind of just go over them and kind of just say, you know, if there's anything there, or if everything's okay. So that's the plan. So today, you know, it's a lab day, so you can ask questions about your labs if there's anything you want to know. Otherwise, for those of you that have finished the lab already, the first lab, I'm just going to start discussing the second one. I'm going to give you some of the basic ideas, as well as doing a quick intro to Python if you've never seen it. You know, just, you know, as I said, remember, it's not about this is not a programming class per se, but make sure that, you know, it's really about understanding the algorithms themselves. Okay, so don't get too stressed about Python. However, you will, you know, I do recommend that you practice it as much as you can. All right, so before I get started with our discussion of the second lab, are there any questions?
Professor Calix, I don't have a question. I just have one thing I want to notify you about. Eric Garati, he will be late by 15 minutes.
Okay, yeah, sure, no problem. So if there are no questions, then you should be now seeing my bright space. So as you know, you're going to be submitting the homework here. There should be a link, Secret Key Lab, and hopefully you've all seen that. So make sure you know, submit your report there, PDF. The next lab is the topic that we began on Tuesday, which is hash functions, and really integrity is the pillar of information assurance that's being addressed. You know, it's very important, obviously, to make sure that your data is not corrupted. You know, imagine if you were sending instructions about buying stocks, you know, you wouldn't want people to change the price at which you decided to buy the stock or things like that. All right, so definitely an important you know, pillar or primitive, that's the word I was looking for, right? So the integrity or hash functions. So let's discuss, as I said, for those of you that have finished homework 1, let's discuss homework 2. So I'm going to open, first of all, the PDF. And the PDF is really just about, there's only 3 problems that I want you to focus on. Share this document. Share. Right, so there's a PDF in there. You can also get the PDF from the seed labs. It's pretty much, they're pretty much the same. Just be aware, follow, you know, we don't always have to do everything in the labs. You know, I sometimes have different, slightly different modified problems. So, you know, work on the ones that I mentioned. I will create the link in a second, and I will basically just say what you need to do. So, a couple of people came in. All right. So the learning objective of this lab is for students to get familiar with one-way hash functions. And message authentication code, Hmac. After finishing the lab, in addition to gaining a deeper understanding of the concept, students should be able to use tools and write programs to generate one-way hash values and Hmac for a given message. Okay, so that, pretty clear. So we've gone over all the theory really of integrity. I believe we got pretty far with that. We covered the algorithm. So I do remember we got far with that. So basically, we're going to use OpenSSL again. As you know, that OpenSSL probably by now you've seen it is the main Linux tool for a lot of these cryptographic concepts. Okay, so you don't have to install it. You've already used it. You have ghex. As you probably know by now, ghex is for modifying the files. So whenever you see ghex, you know we're going to corrupt one bit of our file. Okay, so so the lab tasks that you're going to be responsible for are going to be task 3.1, task 1, generating message digest and Hmac. All right, and that simply is to generate a hash value of a file. So in this task, you'll play with various one-way hash algorithms, and you can use the following OpenSSL command. You can see that there to generate the hash value for a file. You can also, as you know, you can see the manual. You'll replace the DGS type with a specific one-way hash algorithm, such as MD5, SHA-1, SHA-256. So as you know, MD5 has been now considered to be insecure, and so what happens is the algorithms then get replaced by SHA-1 or SHA-256 with, they have more complexity. We won't go into all these algorithms. So, but again, the term project at the end of the semester is a great opportunity for you to implement the algorithm and in your presentation and discuss one of these if you'd like. So we will just pretty much cover the basic idea of a hash with our simple algorithm on Tuesday. In this task, you should try at least 3 different algorithms and describe your observations. You can find the supported one-way hash algorithms by typing man OpenSSL. So that's really it. I mean, the problems in the PDF for this lab are very easy. Okay, these 2 labs are very straightforward. They're again exploration type labs. You're only trying out the tools. Okay, so first do that one and look at the MAC addresses. And again, the goal is to write your observations. Task number 2, or 3.2, is the keyed hash and Hmac. So in this task, we would like to generate a keyed hash, so a MAC address that has a key for a file. So same idea. We can use the -Hmac option. This option there may not be a lot of documentation, but it's supported by OpenSSL. So here's an example of how to use it for the MD5 algorithm. The string following the Hmac option is the key. So you can try, the different algorithms and try different keys of different sizes. So you can see here, it says, please generate a keyed hash using Hmac MD5, Hmac SHA-256, Hmac SHA-1. For any file that you choose, and then please try several keys with different lengths. Okay, so make sure you do that. And then do we have to use a key with a fixed size in Hmac? If so, what is the key size? If not, why? So if you remember, the definition of a hash function that we discussed on Tuesday was that it was a function that mapped something that was variable length and could be very big to something that was fixed length. All right, and that's the key thing. You could have something very big, but it's always very big or very small. You always get a fixed size value, and hopefully it makes sense now that it's because of the, for instance, what we did on Tuesday was creating blocks, right? So we had those blocks, and that, that was our approach. And that's it. So that's, pretty straightforward. And then then we have task 3.3, the randomness of one-way hash. So here, as you might imagine, this is where you're going to corrupt one bit, right? And see what happens using ghex. So to understand the properties of the one-way hash functions, we would like to do the following exercise for MD5 and SHA-256. You're going to create a text file of any length, okay? And then put, with some content in it. And then you're going to generate a hash value, H1, for the file using a specific hash algorithm. Then you're going to use ghex to flip one bit of that file, right? And now you're going to recalculate or regenerate the hash value, but now you're going to call it H2. So now using the modified file, the one that you corrupted one bit of it. And then after you've done that, you're going to observe whether H1 and H2 are similar or not. And you're going to describe your observations. You don't have to write a program for this, so you can skip this part. That's not necessary. But everything else you should do. So that, as you can see, you're going to be responsible for 3.1, 3.2, and 3.3. And that's it. From this PDF, that's all I want you to do. You don't have to do 3.4. We're going to skip that topic. So only the first three. Task 1, 2, and 3. And then as you can see here in the submission, you need to submit a detailed lab report to describe what you have done and what you have observed. You also need to provide an explanation to the observations that are interesting or surprising. In your report, you need to answer all the questions listed in the lab, okay? And provide screenshots, please, just to show evidence. That's convincing evidence that you have completed the task correctly. All right, so that's what we have to do in the lab. Okay, so I'm going to go now to Brightspace, and I'm just going to create the link for you so that you can find it. Let me go to Brightspace. So you should be seeing Brightspace now. So secret key encryption, so hash functions. So here I'm just going to create a new assignment. I'm going to call it hash homework. Okay, this is going to be due. So today's the 10th, right? So it's going to be due on the 17th. And then by what I'm doing is I'm putting 11 p.m. here, and that should be 10 p.m. Central. And then also, I like to, hopefully this, because Brightspace is new, but I believe when I do this now, it stays open a couple of days. Did you guys notice that when I, for this actually this homework is due tonight, right? So let me know if it should stay open for at least one extra day. It's going to mark it late, but it's going to leave it open for an extra day. What I do there, as I told you guys before, is I have a soft deadline and a hard deadline. So the idea is try to make the soft deadline, but you do have a chance. But if you miss the hard deadline, you won't be able to submit. So complete the first 3 problems in the attached PDF. So it would be tasks 1, 2, and 3. So basically what I just discussed, right? So complete the first 3 problems in the attached seed lab. In the attached Seed Labs PDF. Additionally, you're going to complete, and I'll discuss these in a second, the 2 problems in the attached Word document. Okay? So you're also going to complete those 2. All right, so that's it. That's the homework. Are there any questions about this assignment? You should all.
Tests.
Are there any questions?
Yeah, can you hear me?
Yeah, I can hear you. Let me turn up your microphone a little bit, but I can hear you.
It might be because I was talking kind of quiet. Is it a bit better now?
It is better, yes.
You said for task 3, we don't have to do that programming option, correct?
That's
I'm just
right.
confirming.
You don't
Okay.
I just want you to corrupt a bit, and that's it.
All right, cool. Thank you.
That's it. Okay, so all right, so I've written here. You can probably see the link now. In hash functions, I've created the homework. I usually try to put the word, HW there always to indicate that's your homework. So complete the first 3 problems in the attached Seed Labs PDF, task 1, 2, and 3, and complete the 2 problems in the attached Word document. All right, so now let's take a look at the attached Word document. What I mean by that. Okay. So here you should see these right now. Hash functions. You should see 2 problems. I had discussed these problems on Tuesday, but I'll just kind of repeat them. So you just have to do these. So the first problem is, after you've completed the 3 problems from the PDF, you will know how to hash things, right? So that's the point of that PDF, just to show you how to hash something with OpenSSL, the program in your VM. So then now that you know how to calculate, hash values, I want you guys to craft an experiment where you could send a file to your classmate with the hash value. So you need to send the file and the hash value. Your classmate should validate that the integrity of the file has been maintained. And you need to understand that concept, right? So you can use email for this task. And I will give bonus points. You need to specify in there, this is for bonus points. But, for bonus points, I will give bonus points, or bonus points will be given if you can also encrypt the file before transmitting it. So basically what you learned last week, right? So last week you learned how to achieve confidentiality with OpenSSL through DES, AES, right? Today we are learning about integrity, right? And so with hash values using the MD5, SHA-1, SHA-256 algorithms. So what I want you to do is, do that. So bonus points will be given. These are easy bonus points if you can also encrypt the file before transmitting. This last step would provide confidentiality. So you will need to work on this problem. This is one of those problems where you need to work with a partner, okay? As I said, this course requires you, through some of the labs, to work with a partner, okay? Definitely, work with a partner. All right, and today during lab, if you don't have somebody to work with, just find a person through the chat, I guess, and start talk about how you're gonna do things. Maybe via email. You'll have to exchange emails, that kind of thing. All right, so that should be that, and then the second problem is going to be this one. So the Python coding problem. So this one serves as a little bit of an introduction. So like I said, I will do a brief description of Python, just the basic things. And then we're going to use our VM for this, Ubuntu. And then what I want you to do is I want you to write your own cipher encryption scheme. So we're going to be doing a substitution cipher, right? And so the idea with this is that even though this is totally insecure, and it's because there's a pattern, right? There's totally a pattern. I mean, that's the whole point of it, that this has a pattern. It's still not straightforward to implement, actually, but in a way, you're kind of cracking the code, if you will, right? So this is almost about cracking the code, because what I will give you, is kind of like the basic layout or outline of the code, but I will not give you the pattern. And so that's what I want you to figure out. You know, you need to figure out, it's really like a little equation. When you figure out that equation, you've cracked the code, okay? And so that's sort of the idea. So so basically I'm gonna describe the cipher. So the scheme is that you will write a program to illustrate the use of encryption and decryption techniques. You're going to convert alphabets to numbers and back. Okay? Assume you have an alphabet of 26 letters, but you can also include numbers. That would work perfectly fine. An alphabet of 26 letters where each letter is represented by a number from 26 to 1. In this case, the letter A is 26, the letter B is 25, and so on. You will need to show that your program is working correctly by encrypting and decrypting a phrase such as, this is ITS350 at Purdue University. There cannot be groups of 3, guys. So it has to be only, you know, because it's encryption, right? So, you know, it's a 2-party Bob and Alice kind of thing. So just groups of 2. And that's it, okay? So what I will do next, I think, basically, you know how, so hopefully by now, for problem 1, you know, it's with OpenSSL. You cannot work alone. So I wanna stress that for these crypto problems, I intentionally make you work with a partner, because sometimes when you do things, you can do, so let me put it this way. Sometimes a student does everything by themselves. So they're the only, you know, you think, oh, I'm gonna be both parties. And they think they understand everything. But the second that I make that person work with a partner, they realize, oh, there's several things that I don't understand about cryptography. So the best way for you to understand how to exchange things, the keys, is to actually be forced to work with a partner. Okay, so you do have to work with someone else. Okay. So I think there should be enough people, so where we don't have where we don't have groups of 3. I mean, if you're in a situation where you can't find a partner, then let me know, and maybe we can have, maybe some person can volunteer to work independently with 2 people. Okay, but it's not a group effort. It should be more of an individual thing. Okay, make sense?
Yeah.
Okay, great. Yeah, so as I was saying, for problem 1, OpenSSL, confidentiality, and integrity. Keep in mind, I am not going to, usually in the future in exams and everything, this is all I'm going to say. Oh, achieve confidentiality. Oh, achieve integrity. I'm not even going to say which algorithm or anything, right? So the idea is that you need to be very, you know, certain of both of these. Okay, so that's why I want you to practice quite a bit, because the algorithms will start to get. Remember, we're still in the primitives phase, And we still really haven't used two techniques to create a bigger one or more complex one that achieves more objectives. And so all of that, we're going to start building up on these. Okay, so definitely work on this one for now with your partner. And then what I will do now next is I will do this. All right, so I'm going to start with the Python coding problem. I'm going to switch over to the VM. And I'll, I will address that. So are there any questions so far?
Not at the moment.
Okay, great. So if there are no questions, then switch over to your virtual machines, and I will do the same. And we will start doing that part. All right. So maybe keep close this idea of the problem that we have to work on. Remember also, I believe last week, I think I gave you an Ascii table. Let me double check. Yeah. If you go to, let me switch. If you go to Brightspace, under the secret key, you will find the Ascii table. You will need this, right? Because, you will just need it. So it'll help you to solve that problem.
Professor Calix, could I ask just one question?
Go ahead, please.
So our lab, if we read the chapter in advance, I'm assuming that would be quite helpful in completing this lab, correct?
Sure. I mean, the chapters do align really well with the labs. This problem, the coding problem, is not exactly in the book, so you just kind of have to follow along with me. Some of it will be just figuring things out. But the commands are given, right, for this hash. So you just have to create a file and run it. Does that make sense?
Yeah, kind of.
Okay, so do you have a specific question of something that you don't understand?
Nothing specific. There were just a few things that I was more generally concerned, and I was just, because I read the chapter yesterday, I was just wondering if I was kind of overcomplicating it, and by reading the chapter, it would kind of aid me through the lab.
Well, I mean, all I can say is if you have a specific question of where you're stuck, just show that, right? So you can share your screen. I can take a look at where, what it is that. But yeah, remember, a lot of these problems, these are easy. The first 2 weeks are very easy. As we keep going, the problems will get a little bit more challenging. So just, you'll have to kind of work through things. All right, so I've read the problem. Now we are going to go over, as I said, the focus is not so much on writing the code, but certainly it helps. Let me share the screen to the VM. Okay, so you guys should be seeing my VM. So hopefully everyone is here, right? You've done the first lab, so now you're familiar with this. Again, you're familiar with finding the terminal, right? And then there's your terminal. And then, just navigate to the desktop or wherever you're saving your files. I just, I'm saving them here. I'm going to save them in this folder, right? Just so I can find everything. And we were working, I did that example last week where we took my secret file and basically encrypted it, right? We did cat cipher, and there's the encryption of it. So today you're kind of doing the same thing, but just hashing instead of, so you're creating these hash numbers And that's pretty much it. So, you know, you're kind of pursuing that. Now, as far as, you know, with Python, you can use any editor that you like. Gedit is fine. I just, you know, I'm going to use Nano. And let's call this basics, maybe. .py. So I'm just going to write some simple things, some simple suggestions that you need to have in Python. So Python has no variable. You don't need to declare data types. So you can just do like A12, B in double quotes. This is a string, right? And you have those two. And then you can print out your results, print A, print B, right? And so to save, all you have to do is Control X, then you hit Y for yes, and then enter, and that's it. So you can see the file is there. Now, whenever you want to run it, you just do Python basics, in this case, .py. And when I run it, you know, it prints out, this is a string and the number 12. Okay, so that, you know, that's pretty straightforward. If I want to reopen the file, just nano and basics.py, right? Go back to it. So what are a few simple things that I can do? You know, if I want to do, so the main idea is, how do you address curly brackets in Python? We're used to that when you program. Instead of curly brackets, you have indentation in Python. So for instance, if I was going to write if, and I'm going to have, you know, C here equal 5. So if I was going to have if A greater than C, right? Notice over here that I, instead of writing then like you do in pseudocode or something, I would write colon. Then when I hit enter, I need to, instead of curly brackets, open and close, I need to indent. So I'm going to do 4 spaces, 1, 2, 3, 4. Okay, and that allows me now to write the code that goes in here. So I'm going to say if A is greater than C, then, you know, print A, for instance, right? Now, if I want to do an else, notice all I do is else, colon again, hit enter, indentation, 1, 2, 3, 4, and I do print C. Okay, and so that's really all you have to do. So now, you know, we can run this one as well. And there you go, 12, right? 12 is the greater. That's it, pretty simple. Remember, I provided in the resources a document with a lot more examples. This is just a quick review. Now, for loops, you might want to do for I in range, and you specify the range. So for instance, if I just say, I could say from 2 to 8, and it goes from that range, or I could just say 10, right? And it's going to iterate 10 times. Starts at 0, and again at the colon. Just remember, whenever there's a colon, indentation follows pretty much. So 1, 2, 3, 4, and then you can just do print I, and that's the same idea. Okay, so Control X, Y, enter. I'm going to run it again, and there you go. 0 through 9 printed. So another thing you can do is you can create lists. So I'm going to create, so every array pretty much in Python, in the standard Python is a list pretty much. There's also the dictionary. We're not going to need dictionaries in this course, so we don't really have to address it. But here, I'm going to create list of, let's say list of keys, you know, or list of blocks, right? So that's actually something that you guys will be dealing with at some point. And so we just use the square brackets. And so now, you know, I can create this list can have strings, integers. It can actually have other lists. It can have tuples. It can have a lot objects in general, you know, what have you. So here, block 1, comma, block 2. Oops. Block 2, comma. So this is kind of what we did last Tuesday, and then this one would be block 3, for instance, right? So I've created a few blocks. So now I can actually iterate through these blocks as well. I can just say for block in list of blocks. Colon again, remember, and then indentation 1, 2, 3, 4. And then, you know, I can do whatever I want, such as print block. All right, so if I hit enter here and run it, so remember to save, Control X, Y, enter. Now I'm going to run it. And there you go. I iterated through my 3 blocks, block 1, block 2, block 3. Okay, let's see what else. So if I do, going back to the code, I can also do functions. So a function is, you start with the word define, and then you can do, you know, my function. Remember, Python is case sensitive, so pay attention to that. Define my function, as you might imagine here, colon again, for the colon indentation, so that's 1, 2, 3, 4, right? And now you specify what you want this function to do. So this function can, you know, let's just say A equal 4, 1, 2, 3, 4, B equal 5, and let's actually pass a parameter here, C. Okay, so then you're going to say, oh, 1, 2, 3, 4, answer is equal to A plus B plus C. All right, so in that case, 4 plus 5 is 9, and I'm going to pass 1, so that it'll be equal to 10. So then 1, 2, 3, 4, return. Also, sometimes for more readability, you can add, you know, pound sign as a comment, so it allows you to make your code a little bit more readable. Okay, and so now you can, this returns a value, so you can say, I want val equal my function, and then provide a parameter such as 1 in there. Okay, and now we can print out the result, which should be 10. Hopefully. Right, and you can see that there. So I do Control X, Y, enter, run the code, and there you go. There's our value, 10. Does that make sense, guys?
Yeah.
Yeah, so it's pretty simple. Just wanted to give you a quick overview. Python is very much object-oriented, so a lot of everything is an object. Variables themselves are objects, and they have properties. Okay, so now what I'm going to do is I'm going to give you the basic code to start that problem, right? So we're going to start the substitution cipher, which is really about replacing letters with numbers, right? So your encryption is gonna be all numbers. So that right there makes it not very not super secure, but at the same time it makes it a good, interesting exercise. So I'm gonna do nano here, and I'm going to call it substitution cipher .py. Okay, so I start the code. I'm just gonna add a comment here, Control X, Y. So now if I look at the files, you can see it there. There's my file. And that's it. So now let's go ahead and work on it. So you probably want to follow along. I would recommend that you do that if you can. I should be recording the video though, so hopefully that'll be there as well. Okay, so there are obviously a lot of ways in which you can solve this. So I'm just going to provide, and feel free to write your code however you want. I'm just going to provide an example of how you can write this. So let's say you could create, for instance, a function for encryption and a function for decryption, or you could create just one single one. It's really up to you. But let's start with the main idea of this. Okay, so the main idea is that you're going to provide the plain text. And the plain text will be now in Python you can use 2 double quotes or 2 single quotes, but you can't mix a double quote and then a single quote. So one or the other. All right, so then just say, this is ITS350 at PNW in Hammond, some sentence that you want to encrypt, okay, using this substitution approach. All right, and then so that's my ciphertext. Then you're also going to need this is the plain text. Then you're going to need the ciphertext. This, of course, you don't have, and it'll be generated for you by the algorithm. So for now, I'm just going to leave it as question mark. Then after that, you need to basically encrypt and decrypt, right? So here you can create a function that returns the ciphertext. So we're going to call it encrypt, or maybe my encrypt, right? And you're going to do that. And this will be generally the approach. You're going to provide the plain text in here. Right? And then once you have the ciphertext, you want to test this to get your message back. All right, so then you're going to do new plain text, because you're going to compare these. You're going to do new plain text, a different approach. And you can create a function, my decrypt. Okay, my decrypt. And you don't have to worry about error handling or anything like that. Don't worry about that. Just make sure your inputs are correct. So my decrypt, the input to it obviously would be cipher. You guys see that?
Yeah.
All right, so once you have that, I want you to compare them. So you're going to do if cipher text if ciphertext equal new, no, sorry, if plain text, that's what I meant. If plain text equal new plain text, usually this is what you do in programs. You do these comparisons, you check the hash, you check this or that, right? So you'd have some kind of an if statement. So if plain text equals new plain text, 1, 2, 3, 4, then print, you know, it works or it matches. I would also recommend that you print out the results so you can see it. Certainly print the ciphertext and also print the new plain text. So it'll help you in debugging to figure out what you've done right or wrong. Okay? So that's the general idea of how this is going to work. So this kind of illustrates, now I'm not going to run this code obviously because I want you guys to finish it, but I need to, so I'm going to get you started with the functions, right? So I'm going to get you started with my encrypt and my decrypt. Now you could easily just write this on your own, but just I'm going to help you out a little. So remember, define my encrypt colon and then 1, 2, 3, 4. And so now here, you know, I'm just going to put a comment because this is where you have to figure it out. We can add another line here. Define my decrypt, again, colon 1, 2, 3, 4. And you'll have to work through these. So you have to think about the things that you're dealing with. So as our encryptions get a little bit more complex, as you have seen already with OpenSSL, the encryptions actually become binary, right? They become data types like binary, but or hexadecimal. But here we are only going to be dealing with strings, right? Strings of letters, strings of numbers. So that'll make things a lot simpler for us to deal with this. Later on, though, we will come around to that other idea. All right, so what do you need to do? So there's several things that you can do, okay? But the main idea is that you're going to have an input, right? So for instance, in my encrypt, you're going to have encrypt takes the plain text. So I'm just going to call it text to simplify things, right? And now what do you have to do? You have to take each letter and iterate through it, right? So you have to do something like 4 letter in range. And then this range is defined by the length of the letters. So then you can say length of text. Okay? So by doing this now, you'll be able to print out 1, 2, 3, 4. And then now within the for loop itself, we need to indent again. So I'm going to do 1, 2, 3, 4. And then now you can easily print out each letter, right? And so you have, you know, this is, so THIS, right? All those letters, you have them there. Now that you have the letters, you're going to use a very convenient set of functions that Python has to convert letters to ASCII characters. So that's really the trick in this one, right? That you can just take the letter, convert it to its corresponding ASCII number, and then remember, though, that it has to be A is 26, B is 25, and so on. So it has to be that equivalence. But really, I'm going to give you at least a function to convert each character into each letter into
ASCII.
Yeah, the corresponding ASCII number. So I was thinking about something actually that I'm going to say that instead of doing it like this, do it like this. For I in range, length of text, because that way, this may be more, you may be more used to this. So I just changed it a little. So now instead of getting letter, just do this. Letter equal text I. So I feel like this will be a little bit more what you're used to. All right, but it's kind of the same idea, right? So do that text I letter. So now you have the letter, you can print it. And now the trick is, given, let's say you have a letter like A, you know, 1, 2, 3, 4, 1, 2, 3, 4. That letter can be converted into its equivalent number, right? So let's say letter number. And the built-in function for this is called ORD. So if you use that function in Python, given the letter, it should convert it to the equivalent ASCII number. And you can actually convince yourself by taking some letters, printing them out, comparing them to the ASCII table, and you will have a number, right? So for instance, if I go to the ASCII table and I printed the letter uppercase T, that would be 84. Okay, so let's say that I have T and that's 84. Okay. So I have it, you know, this would be 84. So now you got that number. However, you have to know what T should be. All right. So one suggestion that I do make to simplify things at first is actually make everything lowercase. That will make things a lot easier. I'm pretty sure later on you will figure out how to make it work for both uppercase and lowercase. It should be pretty straightforward, but I do think to avoid confusing yourself at the beginning, just start with everything being lowercase. You'll see that the ASCII table actually will allow you to use either one. Does this make sense, guys? Are there any questions so far?
Seems like it makes sense.
All right, great, excellent. So now that I've converted characters or letters to numbers according to the ASCII table, then the next question is now the next question is, you need to convert. So that part I'm not going to tell you because I'm just going to call it figure out the pattern. Figure out the pattern. This is what I want you to do, right? Crack the code. So because it's if you immediately saw ASCII numbers in there, you'd be, that would be the first thing you would try. I'm just going to try ASCII numbers. But when you try the ASCII numbers, you will see, no, it doesn't work, with ASCII numbers. And that's because, remember I said A is 26, B is 25. So you actually have to crack that code. Okay, and that's what I want you to figure out how to do it, and so on, with a pattern. Okay, you need to pattern. So there's got to be some, so what you have to do here is you have to write some equation, you know, calculate conversion, right? So that you do from, oh, you know, yeah, basically that's all I'm going to say. Let you guys figure it out a little bit, ask questions maybe. But that's the part that you have to do. Okay. And then you're going to store those numbers as strings. The other thing you have to think about is that the numbers you're getting now, you need to not add, but concatenate the numbers, right? So you're going to concatenate, I'm going to say the numbers as strings, because that's the cipher as a string, given that that's the cipher that you are generating. Now there may also, if we go to the Ascii table, right? So if we go to the Ascii table, you will see here are the numbers. Okay. Some numbers have 3 values, or some letters have 3 values, some letters have 2 digits, right? So you will have to think a little bit about that. If you have the number 81 versus the number 113, that's actually 3 digits versus 2 digits. So how are you going to encode that? Okay, so I kind of leave that to you to figure out, but you just do it however you want, just be consistent, okay? Be consistent in the way that you do it. And that's really it. After that, this function, once you've encrypted, you know, once you have your concatenated strings, then 1, 2, 3, 4, you just return cipher. All right, and so initially, at the beginning here, you need to create the cipher. Remember, this will be a string, so you initialize to nothing. And then you're going to be appending or concatenating to it until you have your cipher, okay? So that's the encryption, and then the decryption is just the opposite of that, okay? So
just so you know, we can't see your VM. We're still on the ASCII codex.
That's the problem with this. Yeah, so sorry, I just added, I added the return, right? I added the return here. And then also up here, I initialize cipher to be a blank. Okay, so that's the encryption, and then the decryption should just be the reverse of that. And it's going to involve now, you also, for the decrypt, you have a built-in function to convert numbers back to characters, right? So now it's from the ASCII table, I have a number, I want the equivalent character, right? So then it's going to be something like this, number code. Imagine that's the code that you have. But again, you will have to receive the cipher here based on your convention. You know, did you use 2 digits, 3 digits? How did you do it? You're going to have to break that into pieces. You know, maybe every 2 characters, every 3 characters, iterate through that. Each one of those codes, convert it to this. But before that, you probably need to run it through the pattern, right? So again, figure out. So if this one was figure out the pattern, this one will be figure out the reverse pattern. Okay, so remember because it's not going to be the letter, this will give you, given the right number, it will give you the right letter. But basically there's an offset, and you got to figure out that offset. Okay, that's, I said it, you know, that's the idea with this substitution example. Just a really nice warm up for the other algorithms. And that should be it. Okay, so this should be it. So from here, you should start working on figuring this out. Certainly ask questions. The goal is to get, you know, for this to be fun, right? To be a lot of fun. So you get something where you play with the algorithms as well as just using the tools. Are there any, let me save this before I lose it. All right. And then I can open it again. Okay, are there any questions about this problem?
I don't think so. Not yet, at least.
All right, great. So work on this, please. While you guys are working on this, I'm going to look at the students that have sent me their reports just to kind of see if there's anything that I see that they missed, right? But otherwise, just work on this, ask questions, or work on any of the problems of the lab. Remember, this lab is due 1 week from today. Okay.
In your document, could you scroll down slightly?
On this on this the code?
Yeah.
The what part?
Right there.
Professor Calix, someone dropped some questions in the chat.
Oh, give me a sec. Okay, let's see. Yes, if you, so it's lab, so if you know, if you can leave, I mean, I'm not taking attendance anymore. And just ask questions. So it's a lab, right? So you'd work on this in the lab and help you out. Okay. All right, guys. So I've looked at some of the reports, and one important thing is that you need to, in the secret key lab, you need to have the images, right? So in that problem where you so the original image looks like a square and a circle. So when you open those, they still need to be images, okay? Whether it's, you know, there's a pattern or whether it's completely random, that's the answer you have to provide. But just be aware, you shouldn't just show me like with cat, like the data in there. You need to do the thing with the header so you can actually open it as an image, okay? So just want to stress that. That's important in this lab. So what I will do is, for those of you that sent me the email, I'll just reply if I think something is missing on the email.
Professor, can you scroll back up?
To what? To in the code?
Yeah.
There?
Thanks.
Yeah. Are there any questions, guys?
Can you scroll down now?
Scroll down. Here? Or
Yep,
more?
thank you.
Give me 1 second.